All right, good morning. Welcome back to Statistics. So today we are going to be finishing doing test of hypothesis with sigmas unknown, meaning we have to calculate S, and we're going to be using the t-distribution to do that. Okay, so let me go ahead and share a screen and let's get started. All right, so our next problem we have here, by the way, pretty much every question 5 through 10, I looked through them before. All of them are good candidates to put on a quiz. Okay, so I'll try to highlight the ones that I've particularly liked or the ones that I've used before. I haven't used this one per se, but yeah, but we'll get to everything else here. Okay, so community survey sampled 1,923 people. As how long it took to commute to work each day. Sample mean for a one-way commute was 24.2 minutes. Standard deviation 13. So this is all referencing the survey here. Okay. A transport engineer claims the mean commute is less than 25 minutes. Do the data provide convincing evidence that the engineer's claim is true? Use alpha equals 0.01. And we'll figure the rest of this out. Okay, just in case you're ever worried, like if we're going to make you come up with an alpha, we're not. Sometimes I use homegrown problems and people forget to put the alpha in there. If they do, it's 0.05. Okay, so if you don't see it in a problem, okay, and I'm trying to clean up most of those problems that I gave before, or people could just ask me in class, if it's not there, it's 0.05. Okay. All right, so let's have a look and we'll just go through our little 5-step process here. Step 1, what's our HO? What's our H1? Right. Well, what's the engineer claiming? Okay, the engineer claims that the commute time is less than 25 minutes. So we're going to say mu equals 25. You could put a greater than or equals 2 here if you want to. Or mu is less than 25. Right. Our alpha was 0.01. Okay, so that's 1. Here's our step 2. Okay, our step 3 is to calculate our test statistic. And I'm just going to write down all the information I may think is pertinent to doing something like that. Okay, we need an X bar. Okay, so what did we find with this sample? We found that commute time was 24.2. Okay, our S was 13. Okay, and our N was 1,923 people. Okay, so let's see. I think we're set with that. Okay, we're going to use our calculator to do that. Okay, I mean the formula x mu minus S, or no, x mu divided S. That's the actual formula. But we're going to let the calculator do. Let's do this. It's sigma. It's S over. Oh, it's been a while. All right. So let's see here. We need stats. Okay, we're going to go to tests. We're using a t-test because we don't have sigma, we have S. Okay, what's the difference? Well, S does not have quite, S is a statistic as well. It's not a parameter. Okay, what are we looking at here? X mu was 25. Okay, our X bar was 24.2. Okay, S 13. So because it's a statistic rather than a parameter, S is also a random variable. We do not talk about the confidence intervals for S in this class, but there is, there is a chapter on it in the class to do it. Chapter 8 too. Right. So our test statistic here, this is negative 2.6, negative 2.699. Right. Our p-value from that. So here's our test statistic. Our p-value. This is what we really care about because that's what's going to help us answer the question. 0.0035. Okay. So this was 0.0035. Okay, and that's what we care about for that. Okay. Now we're going to be looking at 0.0035, and what was our alpha? Alpha was 0.01. Okay. So this is quite a bit less than a penny, right? This is a penny. So this is a fraction of a penny. It's 0.0035. So the penny would be here. This is actually over some. Okay. So we are quite a bit less. So our p-value, right, is less than alpha. This is the standard we set at the beginning of the problem. Okay. And we said, well, if it only gets to this probability, we're going to say, well, it's random chance. Okay? And since we have a probability that's lower than what we set as random chance, we're going to say, we have to seek some kind of alternative solution here, some kind of alternative explanation. Okay, so here we go with that. We're going to say, since p-value is less than alpha, we're going to say reject the null hypothesis. Okay, reject HO. And then what do we get to conclude? Okay, what are we concluding? We're concluding the engineer is correct. Okay, the commute is less than 25 minutes. I mean, maybe not by much, but it is less than 25 minutes. Okay, so we're going to say the engineer is correct. Is correct. The commute time is just less than 25 minutes. Okay. And there we go. Those are our 5 steps to do this hypothesis. Okay. So let's go ahead and fill in what they wanted to see on the problem. Okay. In the other one, we have mu is equal to 25. Okay. Oh, just that. Thank you very much. And then the other one, mu is less than 25. So we have one-sided test. It's a left-tailed test because we're looking at the left side of the curve. Okay, compute the p-value. Okay, we did that. That was 0.0035. So 0.0035. Great. Checked. Next step, determine whether or not to accept or reject. We said we were going to reject the null hypothesis. Okay. And then we have to say something about what's going on. Okay. There is enough evidence to conclude that the mean commute time is less than 25 minutes. Really all you need to say. All right, and there we go. Okay. So I think this is too similar of a problem than the last one we just did. So I'm going to go ahead and let you guys practice this one and go on to the next one. I'm unlikely to have asked you about this. I'm unlikely to have asked this specific question on a quiz anyway, but it is good practice. Okay. This one be closer to what I would ask, okay, because it's got a whole bunch of numbers we have to deal with. Okay. Let's see. In a study to determine whether counseling would help people lose weight, a sample of people experienced a group-based behavioral intervention, okay, which involved weekly meetings with a trained interventionist for a period of 6 months. The following data are numbers of pounds lost for 14 people. Assume the population was approximately normal, so they got to include that now. Okay. Perform a test of hypothesis. To perform if the weight loss is greater than 16 pounds, use alpha equals 0.10 of significance and the p-value method on your calculators. Like I said, there are other methods. This one is the most common one used today. Okay, so let's do it this way. Okay, so test our hypothesis, HHL, H1. Okay, and let's see what we're looking at here. They want to know if the weight loss is greater than 16 pounds. Okay, so we're going to say mu is only equal to 16 pounds. Mu is less than 16 pounds. Our alpha is 0.10. Okay, so our first step, set this out. 2, set this out. I don't know. One of the previous books, actually 2 things about the previous books. We're going to pause you for a moment. All right, there we go. Okay, so as I was saying, some books have let the reader choose. Don't ever let the reader choose. They don't know anything. You choose. Don't get a committee to choose with you. We need pertinent information here. We need to we're going to calculate test statistic, p-value. Okay, so things that might help us do that. We have the data. Okay, we're going to enter that in the calculator. So we have a whole bunch of those data points. And the calculator actually take care of calculating S while we have it. It has all the numbers. It will calculate S for us. They will go ahead and calculate N, degrees of freedom, everything that would be there. Okay, so we're just going to go through and do that. So we're going to go back to our stats. Okay, we are going to clear list 1. I would recommend doing this rather than trying to delete everything, simply because sometimes you're not dealing with 14 numbers. This is about the size I would give to people put on a quiz, by the way. So that it is one good thing about this question is it's about the same size. I would maximum 20. Okay, that would be about the biggest one I would want. So we're going to edit list 1. Okay, so we're going to have 21.4. Okay, 20.0. Okay, 27.7, 36.8, 6.9, 32.9, 23, 11.4, 20.4, 35.2, 12.0, 120. That would be probably too much weight loss. And this is, let's go back to make this 35 point. Where was that? Where's my 1235.2? That's what I want. Okay, that looks better. Okay, 12, and then we have. So I just want just return here. Come on. 12, and then we have 22.7. Okay, and 16.5. And 18.2. And so we have up to 14. Okay, so that's what they said. And double check this for 1 second here. Okay, 21.4, 20, 27.7, 36.8, 20, 36.8, 6.9, 32.9, 23, 14.4, 20.4, 35.2, we fixed that one, 12, 22.7, 16 points, and 18.2. Excellent. Okay, we're going to go to stat. Okay, we're going to go to tests. We're going to go to t-test. Okay, boom. Stats. We're going to use data this time. All right. So notice they changed the options that we have here. We're going to go to, what did they say? They wanted 16 pounds. Okay, data's in list 1. I'm not going to worry about frequency. We're going to say, was it, oh, at least 16 pounds, right? Oh, I didn't want less than. I think I wanted greater than. Let's double check that. The mean loss greater than 16 pounds. Let's fix our thing here. Okay. We wanted greater than 16 pounds. Okay, if you caught that, we're yelling at the computer, wait, fix it. Okay, I saw it, thanks. We're good. All right. And then, so we're going to go ahead and hit greater than, right? And then calculate. All right, that looks pretty good. Okay, so our t-statistic here, that was our test statistic rather, that was 2.43. 2.43, this is our test statistic. All right, and now we're going to have a look-see on our p-value. P-value was 0.015, okay? And then that's all we really needed to know. Okay, so what was our, oops, sorry, this is 4. What was our cutoff, right? Our p-value is 0.015. Our alpha was equal to 0.10. You see, you know, if yeah, maybe you're working a competing brand of seminar type things, or you didn't like them for some reason, and you said, you know what, I'm going to say it's 0.01. See, if we go with our first choice, right, that we set up at the beginning, we say p-value is less than alpha, okay? So we're going to go reject HL. But after you see the result, you can say, no, I'm going to say it's 0.01. And since this is 0.015, then so this is the correct one. Okay, this is the way they asked to spell in the book. But if I want to do this unethically, then we can change once we know the answer, we can change the alpha and say, oh, I'm sorry, I'm going to go ahead and report this as p-value is greater than alpha, and we're going to say do not reject. So depending on where you set your alpha, you get to make a different decision, okay? And that's not really being fair to your experiment. So you set up your experiment, you decide what your alpha is first, well, not first, but you set up your experiment, you decide on your alpha, then you run the experiment, and then you already have a criteria of what the cutoff is, and you're not allowed to go back and change it afterwards, okay? So it's, again, chance of making a type 1 error, that's what we care about, and that's your decision on what alpha should be. Like, what is a type 1 error for them, and what are the downsides for it? Okay, these seem kind of arbitrary. In textbook problems, they are kind of arbitrary, but in real life, you don't get to decide this. I mean, you should probably not be deciding this as one person's power. Okay, this should be like a couple of people get to make the decision, because you're going to forget stuff. Okay, it's better that several people get to decide what the alpha should be before you run your experiment. Okay. So when in doubt, like, well, 0.05, because that's academic standard. Okay, if your industry has a different standard, pick that. Okay, so in this case, p-value is not greater than alpha, right? Or yes, it is. P-value is quite a bit less than alpha. Okay, it's 0.01 versus 1.0, and we say reject null hypothesis. Okay, let's do this. Reject the null hypothesis. People using this technique are likely to experience 16 plus pounds of weight loss. Okay. All right. All right, HO. Okay, state the hypotheses here. So mu equals 16, or mu is greater than 16. Okay, so we want to, I know it's weird to look at it as like 16 or 16 pounds or greater of weight loss. And like, what is that? Like, it's still the right side of the curve. I know it feels a little weird, but we're not measuring their actual weight. We're measuring how much weight was lost. That doesn't really matter so much. Like how you phrased it. So like how many negative numbers do you want to play with? That's what you're dealing with. Okay, let's see here. Our p-value 0.0153. Okay, 0.0153. So you're going to want it to 4 decimal places. Very good. Okay. Determine whether or not to reject HL. We are rejecting the null hypothesis. Okay. And there is enough evidence to conclude that the mean weight loss is greater than 16 pounds. Okay. And that's all she wrote there. All right. One of the classes I had was quality control. And this was like a classic problem in doing it. It's like, are you filling the beverage cans well enough? Are you putting enough cereal inside of a box? So I did plenty of these problems. So if I have a choice between like number 7 or number 8, I'm more apt to choose number 8. Okay. But I mean, it doesn't really matter too much. Okay. Let's see, we're going to go ahead and do this. So we've got HM, HA. Let's see, the machine fills beverage cans to 12 ounces, but perform a test of hypothesis to say if the mean volume is less than 12 ounces. Okay. So it's either 12 ounces. Usually with these, we care about more than or less than, but maybe this is a consumer group and they're caring more about whether or not you got what you paid for. Okay. So either equals 12 ounces or is under 12 ounces. Okay. We have an alpha equals 0.05. Okay. That's our step 1. Here's our step 2. Here's our step 3. We're just given some data. So we're just going to put that into the calculator and go ahead and do that. All right. And we'll just get started with that. It's also a nice problem because there's 8, n is 8. I like that. Oh, I'm clear. What am I doing? So it actually makes you go through and deal with like entering data in the computer, but you are not there for 10 minutes entering data. Okay, clear list 1, there. Right. And we're going to go to stat, and again, we're going to edit. So what are we doing? Oh, I need my calculator. Okay, there we go. So we're going to say this is 11.98, 12.04, 11.87, 11.95, 11.89, 12.01, 1.97, 12.10. Okay, so that's my 8. Let's just double check real quick. So there. This looks good. Okay, we're going to go to stat, test, enter. We're choosing some data. Oh. In this case, what are we checking for? We're checking if it's 12. Okay. Oh, wait. Oh, I went z-test, sorry. See, they tell us give us sigma versus not. So what we're going to do is we're going to go back to stat, tests, t-test. There we go. Data, 12, list 1. And in this case, we cared about, we wanted less than. Okay, because you could be a consumer group wondering if you're getting the right amount that you paid for. Okay, and here it's like, well, not so much. Okay, not so much. So let's go ahead. Oops, I want this one. Okay, so our data, so we are given our step 4. Step 3 is our test statistic, right? Negative 0.6507. Okay, our p-value 0.26. We'll say 80. Okay, because we have to round this 2, 3, 4. This will be rounded up to 1 next, which will change this one. Okay, and everything else looks good. Okay, so we're going to go and say, well, look at my p-value, 0.86 there. Okay, that's our p-value. And our alpha, 0.05. Okay. Do you remember one of my classes? We did this around Easter time, and they always thought my alpha was a fish. I was trying to convert them to Christianity. I'm not trying to convert you. Okay, my alpha just looks like half a figure 8 to me, but there you go. It's not a fish, it's an alpha. Okay. So p-value is much bigger than alpha, so we should not look for alternative explanations. This was well above the cutoff that we gave them, so we're going to say do not reject the null hypothesis. Do not reject HO. So what does this mean? It means that the volume is likely 12 ounces, and we're not, you're not ripping anybody off. Okay, whatever you put 12 ounces on the can, you're getting 12 ounces, we're good. Okay, so let's see here. All right, state the null alternative hypothesis. So we either have mu is equal to 12 or mu is less than 12, because that's, say they want to know, test if the mean volume is less than 12 ounces. Okay, hypothesis is a left-hand test because we're looking for the under part of it, right, before 12. Excuse me. Okay, compute the p-value of this test statistic. Okay, we got, what did we get? We got 0.2680. Okay, 0.680. Okay. And quite honestly, here's what you're looking for. So at this point, you might be saying to yourself, this seems kind of repetitive and it's getting kind of boring, which means it's getting kind of easy. Okay, and that is exactly what you want. You're like, wow, test our hypothesis. This wasn't hard at all. This was kind of easy. Like, you know what that means? That means I like your chances for doing well on a quiz. Okay, if it's too easy, there is enough evidence to conclude the mean volume is less than 12 ounces. There is not enough evidence to conclude there. We did not reject the null hypothesis. So yeah, if this is starting to become too easy for you, I love it. Okay, that's great. You don't need to be challenged at every corner. At this point, you're kind of looking at it, I hope, you're saying, this looks pretty good. Okay, again, I hate the fact that they actually ask you to do this, because at this point you're looking at this 400. I'm like, which one of these is not like the others? Like, I'm gonna say that I don't think they have outliers. There are no outliers, but I could be wrong. Okay, the dot shot shows no evidence of strong skewness. Okay, this is marginal. Okay, I do not want to put you in a position where you have to think about, like, well, maybe, like, that's a crappy decision for you to make. I don't want that. It is reasonable, and they may overturn me and overrule. That's fine. Okay, but I think they want this to be. All right, they didn't tell me I was wrong, so we're going to go for it. But yeah, I will scrub these problems out of your out of your exam. I don't like that. Again, there are plenty of tests and plenty of if they really wanted these, they should have included this in the syllabus. But we decided not to. Okay. So the following are prices in dollars of random sample of 10 7.5 cubic foot refrigerators. Okay. Consumer organizations reports the mean price of a 7.5 cubic refrigerator is less than $360. Do the data provide convincing evidence of this claim? Really do need. So let's see here. We finish reading this thing. Okay. So HL, what are they claiming? They're claiming that these prices are averaging $360. Okay. The consumer organization says, no, we think they're actually less. That should be a colon. Less than $360. Okay. We're going to keep this as alpha equals 0.01. Okay. So that's our first step. Here's our second step. Just break this down. Third step is we're going to calculate our p-value and our test statistic. So calculate test statistic and p-value. Okay. So we're going to go through a calculator. We're going to clear list 1. All right. And then we're going to go to stat. We're going to edit our list. There we go. We're just going to take these guys in. So this was 339, 303, 401, 356, 350, 375, 307, 320, 341, 328. Okay, these are 10 refrigerators there. Double checking it. So 339, 303, 401, 356, 350, 375, 307, 320, 341, 328. Done. Okay, so we're going to go back to stat, do a test. I'm going to scroll down to where it says t-test. Okay, but that is what it takes. Really want to do that. So our mu, right? What are we claiming? We're claiming $360. Okay, list 1 for consumer 1. And what do they want to know? They want to know if it is less than. Okay, so less than here. And let's calculate. Right. So our test statistic is equals negative 1.878. Okay. Our p-value was 0.04. We'll say that 5. We'll change that to a 7. No, we won't. 0.0465. Okay. So step 4 here, we're going to look at the p-value versus the alpha. Okay, we have your p-value 0.0465, our alpha 0.01. Which one's bigger? Okay, p-value is bigger. So this was our cutoff to say, something is unusual here. We did not make that cutoff. So we do not need to seek an alternative thing. We said, well, our cutoff is 0.01. We didn't find it to be unusual because our p-value is not that small. So we're going to say, do not reject HL. Okay. The average price of these refrigerators are $360, or are likely to be $360. Okay, you can phrase this as to what you're saying. Okay, I'm not really trying to grade your grammar on this, as long as you communicate some way of saying the average price of the average price of the industry is correct. It's $360, whatever you want to do with that. Okay. So let's go ahead and we'll type in our things here. So we have mu is equal to 360. The next one is mu is less than 360. Okay. This is a one-sided test. It's on the left side. I really pondered that left side there. Okay. Sorry. P-value was 0.0465, 0.0465. Oops, I don't want that one. 0.0465. Why do you always write down the test statistic? Because my book needed the test statistic because we did this a slightly different method where we needed the critical value and the test statistic rather than the p-value. Okay, so it's just out of habit, like these are the steps you do. Do not reject the null hypothesis. All right, and there is not enough evidence. There's not enough evidence to conclude the mean price is less than. See, I noticed that when I usually write these, it's a direct statement rather than there is not enough evidence to conclude the price is less than. That's technically the way you want to write it, but it's also confusing to read that. So your boss tells you, like, do this test and tell me what it means. Depending on their education, they might prefer something like this if they're a statistician. But if you're just somebody trying to figure out like how to price refrigerators, say 360 will be just fine. That's the answer they're probably going to appreciate more. All right. This is a very similar problem. The reason I would do it rather than skip it and say we've thought the last two we've done this. I've put this one on a quiz as well. So we'll run through it and see what we get here. Okay. Oh, see, this one far less of a, and again, I scrubbed this part out, but this isn't really that skewed. So there are no dots out here. So there's no outliers. So there are no outliers, and it looks pretty. There's evidence of this. No, there is not. There's no evidence of strong skewness. Okay, so we're going to say we can assume the population is normal, and it is reasonable that the conditions are satisfied. Okay, this if I was going to ever put one on here that made you do all of this kind of box plot would be far more likely of something I would deal with. All right. So state the null, and okay, let's go through the problem here. All right, what do we have? In an attempt to increase business on Monday nights, where a restaurant offers a free dessert with every dinner order. Okay. Before the offer, the mean number of dinner customers was 150. The following are numbers of diners on a random sample of 12 days while the offer was in effect. So they picked 12 Mondays at random and said, what are we doing? Can you conclude that the mean number of diners changed while the free dessert offer was in effect? Okay, alpha 0.01. So what is this restaurant hoping to show? It's hoping to show, well, the special offer had no effect. And then look here, it says, can you conclude that the mean number of diners changed? So maybe these were some of the people that were in that weight loss study and they said, we're not going out while they're offering dessert. Or maybe they said, well, free dessert, let's go there tonight. Okay. I don't know. So we're not making a judgment on are there more customers or fewer customers. We're testing to see whether or not the customer numbers changed. Okay. So this is a two-sided test. Okay, we want alpha equals 0.01. Okay, so here we go. We're going to say our test, calculating our test statistic. We're going to, we have the data. Okay, this used to be a whole process. Put this into your calculator, get the mean, standard deviation, etc. Okay, remember to count the number of days up. Okay, the whole thing. All right, so stat, we're going to clear our list. Clear list one. I don't see, one of the reasons I don't want to just delete them is that, we all get delete happy when we are typing a bunch of stuff in. And the one thing I don't want to do is accidentally delete these L1s and L2s and L3s. Don't try the experiment. There is a way to get them back, but I have no idea what it is. So once you've done that, like, how do I finish it? Like, well, YouTube exists. And for me, it doesn't happen often enough for me to remember how to do it. So let's go 118 and 131. All right, let's just double check this. 185, 121, 148, 130, 170, 153, 139, 189, 81, 71, 18, 131. All right. So we're going to go back to stats. We're going to go ahead and here tests. Go down to t-test. Enter. We are giving it some data. Right. We want to know if they're 50, 150 rather. 50. Find it in list one, frequency one, with two-sided test this time. Oops. Data 150, everything else looks good. We'll go just down to calculate. Okay, and hit enter. Have it think, and then there we are. Okay, our t statistic was 0.4031. We usually go with 2 decimals for those because you don't want to confuse. This is a statistic. Okay, so we're just going to say this is 0.40. What is our p-value? Right, p-value is equal to 0.6946. Okay, your cutoff to say whether or not something was noticeable, right, was that. So our p-value 0.6946, our p-value is 0.01. This is where they said, oh, that's unusual. Did we notice it was unusual? No, this is way too big. So do not reject HO. Okay, your average customer count is still 150. Your special did absolutely nothing. No effect. So do not reject HO. There is no difference in number of customers on days you've offered special. Okay, no change. Okay, so let's go ahead and have a look at what's going on here. Sure. So mu is equal to 150, and our alternative is mu is not equal to 150. Okay, hypothesis test is a two-sided test. We didn't know what was going to happen, either more or less. Just checking. P-value was, what's our p-value? 0.6946. All right. So do not reject the null hypothesis. Okay, do not reject it. And then we have to write something saying what our conclusion is. Okay, yes, you really do. So there is not enough evidence to conclude the mean number of diners changed with the while the dessert offer is in effect. Okay. And there we go. All right, so that should be 9.3 for us. Yeah, 9.3, I believe we just did. So that's what we, so you can be able to do your homework now. The rest of the class is effectively the same idea that we just did. Okay. They change whether or not it's this, that, or the other, but effectively, it's all effectively the same after this. All right. So we'll just go with that and continue from there. Okay, so thank you. And I guess the next value is going to be proportions. Okay, and then we get to chapter 11, chapter 12. Okay. Yeah, chapter 11. Okay, very good. Do your homework.